A modern university campus looks like a single, cohesive institution on a map, but academically, it functions as isolated islands drifting further apart. Recently, university administrators and accreditation boards have pushed hard to bridge these isolated academic islands. They want transparent, standardized ways to measure student success across every department. To accomplish this, teaching centers gather a physicist, a historian, and a computer scientist into a single room for a pedagogical workshop, handing them the exact same rubric. The result is nearly always immediate, intense resistance. This one-size-fits-all approach routinely falls apart, leading to institutional friction and ultimately failure. Faculty are not being intentionally stubborn. They are reacting to an invisible, deep-rooted clash of academic cultures that universal templates completely ignore. The root of this conflict comes down to epistemology, the underlying philosophy of how we know what we know. How a specific academic discipline measures a student's knowledge is strictly dictated by that discipline's absolute definition of what constitutes truth. Look at this flowchart. On one side, you have disciplines where truth is found by exploring an interconnected web of subjective variables and human context. On the other side, truth is a strict binary. An output is either objectively true or objectively false. A grading tool is never pedagogically neutral. A rubric inherently carries the epistemological bias of the specific discipline it was built to serve. Assessment is not a universal, transferable skill. Imposing a universal grading template on every department is doomed because it violates the underlying architectures of how different sciences operate. To map out these rigid architectures, we can look to sociologist Tony Betcher. He famously described university departments as academic tribes and territories, each with its own rituals, language, and ways of defending its borders. We plot these tribes using a sociological matrix built on Anthony Biglin's classifications. On the x-axis, we separate the sciences, hard convergent disciplines on one end versus soft divergent disciplines on the opposite end. The y-axis measures research goals, with pure disciplines at the top and applied disciplines at the bottom. Every faculty member in a modern university operates inside one of these four resulting quadrants. Let's plot the data points. Physics and mathematics land squarely in the hard and pure quadrant. Engineering sits in hard and applied. Meanwhile, fields like history and literature populate the soft and pure quadrant. Let's isolate the soft and pure tribe, the humanities and social sciences. Here, knowledge is viewed as constructed, deeply subjective, and entirely dependent on historical or social context. Their cognitive model is a search for complexity. Just like a drop of dark ink spreading organically through clear water, ideas in the humanities diffuse, intermingle, and actively resist simple categorization. This tribe values ambiguity. They reward students for taking multiple perspectives, showing empathy, and constructing original interpretations, rather than recalling raw facts. To evaluate this kind of thinking, the humanities rely on multidimensional analytic rubrics and unstructured, highly personalized feedback loops. A highly effective tool here is the single-point rubric. It features a single central column outlining core expectations, surrounded by wide, completely blank margins. This design deliberately leaves room for idiosyncratic exploration and customized feedback. This is exactly why humanists aggressively resist standardized scoring matrices. They argue that algorithmic grading destroys the nuance of a complex creative argument. For a humanist, forcing an essay to meet rigid, predetermined criteria narrows the curriculum. Students stop taking intellectual risks and start writing for the rubric, turning free thought into a sterile checklist. Now, we shift across the matrix to the hard tribes, the exact sciences like mathematics, computer science, and engineering. In these territories, knowledge is objective, absolute, and logically provable. Their opposing cognitive model is simplify and solve. To find a verifiable answer, they strip away conceptual noise, much like a watch mechanism relying on precise interlocking gears without excess friction. Because of this demand for precision, these disciplines actively reject the vague, word-heavy grading matrices favored by university administration. Instead, exact sciences rely on rigid marking schemes built entirely on discrete, step-by-step partial credit allocation. This visual shows a mathematical marking scheme in action, breaking down an abstract problem into precise logical nodes. It assigns exactly 2 points for setting up the formula, 3 points for applying the rules of integration, and 5 points for calculating the final limit. When an administrator suggests using qualitative rubric phrases like demonstrates partial understanding, a computer scientist or mathematician finds it semantically useless. It doesn't describe the exact logical step a student failed to execute. In the exact sciences, a single minor error mathematically breaks the entire chain of proof. Grading requires objective numeric values attached to specific actions, not verbal descriptions of a student's effort. So, when you bring these two incredibly distinct tribes together in a single pedagogical workshop, institutional friction is immediate. They are victims of the semantic gap. This is the phenomenon where different academic tribes use the exact same terminology to describe mutually exclusive tasks. Let's map this linguistic divide using the concept of critical thinking. On the left, humanities define it as text deconstruction, analyzing bias, and resolving moral dilemmas. On the right, STEM fields rooted in the scientific method, statistical reliability, and rigid system constraints. When a teaching facilitator asks a mixed room of faculty to build a single rubric for critical thinking, they are unknowingly demanding the creation of two entirely incompatible cognitive tools. Universal rubric templates consistently fail because they completely ignore this deep linguistic and cognitive divide. They ask scholars to betray their own epistemology. The standardization paradox is clear. The one-size-fits-all model in higher education assessment is an epistemological dead end. These isolated islands do not need to be forced into a single, homogenized landmass. Instead, they must be connected by distinct, custom-built pedagogical bridges. To genuinely improve grading consistency and student learning, universities have to abandon centralized administrative micromanagement. The solution is a shift toward decentralized, discipline-specific pedagogical development. Training on assessment tools must occur from within the academic tribes themselves, utilizing their native epistemological language and respecting the nature of the knowledge they produce. For the humanities, this means leaning into tools like single-point rubrics or methods like comparative judgment, seen here, where experts rank complex arguments against one another to evaluate quality without crushing originality under a rigid grid. For STEM fields, it means embracing strict marking schemes and structured empirical tools to ensure total algorithmic and methodological rigor. A simple binary checklist perfectly captures the absolute yes or no reality of a rigorous experimental design in a biology lab. True academic rigor does not come from enforcing bureaucratic standardization across an entire university campus. Effective assessment only happens when the grading tools we use perfectly align with the distinct, uncompromising ways each discipline uncovers the truth.